this example now, which we were working. So these are meals being prepared in a canteen. And so 30 meals cost $40, 35 meals cost $154, 40 will cost $159. So it's I've intentionally called this as the exploratory variable, and the cost is the response variable. So you've got all the information there. I'm going to insert a calculator page, and under menu, I'm going to statistics, stat calculation, and we're going to do two variable statistics calculation. And over there, on the x-axis, the exploratory variable, and on the y-axis, the response variable. And everything else I'm going to leave as it is, and it makes this calculation there. So that's the bit of information. So I just showed you how we use the two variable statistics option on the calculator. Okay, and this just I can also do a linear regression on the calculator, and I'll show you that in the next screen here. So I've just shown you how I can use the calculation. So if I just type in stat dot, you will see actually it comes up with all those things that I would need. So if I'm just looking for the value of correlation coefficient, that's 0.988, which is a very good correlation. All right, so we're going to do a linear regression next, and that also is available under the stat calculation. So I'm going to insert a calculator page, and once again menu, statistics, stat calculation, and this time linear regression. Now you've got two options, mx+b or a+bx. It's really the same thing. It's advisable to use a+bx. So b would give you the gradient or the slope, a is going to give you the y-intercept, and x is obviously the explanatory variable. So let's click that, and in the x list, EV, and that's RV. Now save regression equation. I've already got something saved as F1, so it comes up by default as F2, but if you want, you can actually give it another name. So let's say I'm going to call it regression 1. It doesn't really matter. So I'll remember I've called it regression 1. And frequency list, category list, and this you just leave empty, and you click that, and it actually gives you the equation there. Now, very similar to what we were doing earlier, if I want to see the residual values, you can see I can't read it over there. But if I type over here stat dot residual, now if I go to resid, it will actually put all the residual values. And if I want to see them to 2 decimal places or something, so if I do that, I hope it works. You can see it's actually got all the residual values to 2 decimal places. Now that's more readable. So you can actually get all the residual values. Anyway, going back to the screen here, that's the regression equation. It gives you the value of A. It gives you the value of B there. I'll be talking about R square later, but R square is actually one of the important things there. And then R, regression value, correlation. So 0.988 is a very good correlation. That means it's a very linear relation in this case. So it just explains over there what we've exactly done. So I've got y equals mx+b or y equals ax+b. Both will give you the same information. M is basically the gradient, and if you're using this form, A is the gradient. Now, just to go back over here, as I said, I called it regression 1. Now, if I want to use that equation, if I just type regression 1, you will see it goes bold. And since the variable is x, I type that, it should give me the equation. And if I want to graph this and see it's a straight line, if I insert a graphs page, and if I just type in over the regression 1, X, it will actually graph that for me. And obviously, I need to go and change the scale, but it has a graph. So you can use various options to do that. So if I use the zoom fit option, I can see that my graph is there, and you can see a straight line over there. Okay. And I've just been to this part. If you want to get the residual values, that's how you would get them. So, and I use the round option. So round to 2 decimal places. So that's what I have done over there. Now, I briefly talked about using R-square, coefficient of determination, and we use this for linearizing data, especially when we are going to do transformations. I'll use that. So instead of R, we use R-square, and obviously the closer the value of R-square is, the better it is. Okay, actually that's not R-square, that's R, so that's a mistake there. That value will give you R. But this syntax I've got over there using the correlation matrix. All you need to do is put X variable and Y variable. So I'm just going to demonstrate that over here, which also can be found under so I'll insert a page here. And this is one of the quickest places for you to identify the linear relationship. So let's go and insert a calculator menu, go to statistics and stat calculations, and in the stat calculations, right at the bottom, you see correlation matrix. And if I put EV there, explanatory and response variable, you see it gives me the value of R. So this is one of the quickest places to check the value of R without doing any calculation or anything.